everyone. Today we are going to discuss a very important topic of ray optics, that is refraction at spherical surfaces, and hence we will derive Lensmaker's formula. For that, the ray diagram is as it is. Observe on the board. This is a refracting surface. This side medium number 1, that side medium number 2. And refractive index of medium number 1 is mu1, refractive index for medium number 2 is mu2. We have assumed that mu2 is greater than mu1. It means medium number 1 is rare and medium number 2 is denser. Object is kept in rare medium. So a ray of light is passed through like this. After refraction, it will bend towards the normal because it is passing from rare to denser. As rule suggests, so it will bend towards the normal. See, I have drawn a normal on this surface. So ray was supposed to go like this. So it has bent towards the normal. And you know, any normal drawn to the surface will always pass to center of curvature. Now, see, this ray after refraction, they are not going to meet. So we have retraced this path backward. Now they are intersecting here. So this is another ray which is passing normal. So we will pass as it is. So this ray after refraction will not meet in the forward direction. So we have retraced and now they are meeting here. So final image is formed here at I. So object kept here and image is formed here in the same medium. Now the angle, let us discuss the angle. This is incident ray and this is normal. So angle is angle of incidence. This is refracted ray and this is normal. So this is angle of refraction. Now see, if this is I, this is R. So this will definitely be, this angle will be I minus R according to vertically opposite angle. If it is I, the vertically opposite, total vertically opposite angle should also be I. Add this to R and minus R will be cancelled, you get again I. It means if it is I, so there should be I minus R. Now, object is kept in medium number 1, that is rear side. And what is the shape of the surface? The shape of the surface is convex. Bulge at the center, that is the definition. Now, we are going to write at point P. At point P, we are going to write Snell's law. Snell's second law. What it says? Sine of angle of incidence to sine of angle of refraction is equal to what? It is equal to refractive index of medium number 2 to refractive index of medium number 1. This can also be written as mu 1 2 or simply mu. That is, it is passing from medium number 1 to 2. Now, here are some assumptions we are going to write. Since aperture is very small, what does it mean? This M and N are very close. So that why? Because aperture we have taken very small. So therefore we can write sine theta is equal to tan theta. This is the assumption. Why? Aperture is small. So this is the assumption. You must remember. Now let us substitute. So sine I will be written as I only, because sine theta is equal to theta, so sine I will be equal to 1 and divided by sine R is equal to R is equal to mu2 upon mu1. Let us do the cross multiplication. So mu1 I, mu2 R, cross multiplication. Now we will substitute the values of I and R from the diagram. Just try to understand the values of I and value of R. Observe. So see, this is I, angle of incidence. So observe this triangle OCP. For this triangle OCP, this I is an exterior angle. OCP, an exterior angle I. So what is the property of exterior angle? Exterior angle is equal to sum of interior opposite angle. So I will be equal to alpha plus gamma. Now, what is R? Angle of refraction. Observe, this is the diagram. Triangle CPI. Triangle CPI. So this is exterior angle for this triangle. So this angle will be equal to beta plus gamma. Remember this, always we are going to take angle alpha with the object, angle beta with the image, and angle gamma with the center of curvature. This you have to remember. Now let us substitute the values. So mu1 in place of I, you write in place of I alpha plus delta gamma. Mu2 in place of R beta plus gamma. Do the multiplication. Mu1 alpha, mu1 gamma. Inside mu2 beta, mu2 gamma. Now keep this gamma one side and this side. So we will transfer, little rearrangement. Transfer this side. So it will become minus beta, and mu2 gamma, this you transfer that side, this side. So it will become minus mu1 gamma. So this will be written as it is mu1 alpha, mu2 beta. Here we can take gamma common. So mu2 minus mu1 gamma outside. Now from the diagram again, we are going to substitute the values of alpha, beta and gamma. Observe, alpha can be written as tan alpha, assumption. Theta can be written as tan theta. So alpha can be written as tan alpha. Observe the diagram. What is tan alpha? So here is alpha, tan, opposite upon adjacent, opposite upon adjacent. So what is opposite? That is Pn. What is adjacent? On. Next, value of beta. So beta will be written as tan beta is equal to, observe the diagram, this is written, so opposite Pn upon adjacent In. Last one, gamma. Tan gamma is equal to, observe the diagram, this is gamma, so opposite Pn upon adjacent Cn. So these are the values of alpha, beta and gamma. We will substitute here. Let us substitute. So mu1 will be written as it is alpha, that is Pn upon On, minus mu2 beta will be written as Pn upon In is equal to mu2 minus mu1 into gamma, the value of gamma, Pn upon Cn. So observe on the both side here, Pn will be taken outside as common and that side Pn outside. So this Pn and this Pn will be cancelled out when you take it outside common. Now we are left with mu1 upon On minus mu2 upon In is equal to mu2 minus mu1 upon C n. Now again observe the diagram. What is IN? See what is IN. So IN is basically this is image. This is image. The distance of image is shown by V, and what is O? This is object. The distance of object is shown by U. Now see mu1 as it is upon ON. So ON is U and ON is U, and it is kept on the left side. Incident ray on the right side, and we are measuring the distance on the left side. So we write here minus U. Mu2 IN, again image is found on the left side, so it will be minus V is equal to mu2 mu1 upon what is Cn? Observe what is Cn, that is radius of curvature, and it is on the right side. It will be positive. Now do the calculation. This minus and minus will become plus. So mu2 upon V, and this is mu1 upon U is equal to upon R. This is the small derivation for refraction at spherical surfaces, that is mu2 upon V minus mu1 upon U is equal to mu2 minus mu1. So this is mu1. So same this last equation, mu2 upon V and minus mu1 upon V is equal to mu2 minus mu1 upon R. This we are going to use to derive lens maker's formula, which is very, very important. So this is the simple diagram for to derive lens maker's formula. Let us try to understand. Object O, here it is kept at this side. So this side mu1, inside mu2, again outside mu1. So medium number 1, medium number 2, again outside medium number 1, same medium. So object, a ray of light is passed through like this. So this is surface number 1. Surface number 1, draw a normal. So you know this normal will intersect here, and this point will be C, center of curvature. So from here to here the distance is R1 for this surface number 1. So R, radius of curvature R1. So it will bend towards normal. So it is bending towards the normal. Again final here, when it reaches to this surface, again draw the normal on this surface. So this will intersect here at this point. So this will be C2 for this surface number S2, surface 2, center of curvature C2. So the distance is R2. Now the final image is formed here. See, refraction here at this point, refraction at second point, and final refraction image is formed here. When a ray of light passing through like this here on this surface number 1, suppose this surface number 1 is surface number 2 is not present. So what will happen? A ray of light will go like this, a refraction, and it will pass through like this. So intermediate image I dash will be formed. So for this surface, object O is here. For surface number 1, object is kept here and image is formed at I dash. Now for surface number 2, object, where is object? For surface number 2, now object is here, I dash. So this is the object for surface number 2, and image is formed here at I. So for surface number 1, object is here at O, image is formed at I dash. For surface number 2, object, this image will act as object, and final image is formed at I. So these are the distances: object distance U, final image distance V, and R1 and R2. Let us write the equations as we have written for refraction at spherical surfaces. For surface number 1, surface 1, let us write the equation. So as you know already, we have written the equation, that is mu2 upon V minus mu1 upon U is equal to R2 minus R1. Sorry, we have written mu2 minus mu1 upon R. This we wrote. So since we are writing for surface number 1, so we write for surface number 1 is as R1. Now let us substitute the values. Mu2 as it is. Mu2, where is image V, means image distance. So for surface number 1, where is the image distance? From C to I dash. So this is image C to I dash, and this is on the right side, so we write positive. Minus mu1 U. U means image distance, where it is from, where it is kept on the left side. So right here minus CO is equal to mu2 minus mu1 upon R1. It is on the right side. See, from here to here, for this surface, radius of curvature will be on this side. So this is R1. So this is on the right side. Write positive plus positive. So this is for surface number 1, equation 1. Now for surface number 2. Now light is going here, and on surface number, for surface number 1, light is going from rare R to D, rare medium to denser medium, rare to denser. Now for surface number 2, light is going from where? It is going from denser to rare, rare to denser, now denser to rare. So for denser to rare, there is a trick. There is a trick to write this equation. We will replace mu1 by mu2 and mu2 by mu1. That's all. So this is written mu2 by V. So we write here mu1 by V minus, it is written mu1. So we write mu2 upon V is equal to, similarly here also, mu1 minus mu2 upon R, and this is R2. Again observe. So we will replace original equation. In the original equation, mu1 by mu2 and mu2 by mu1. In place of mu2, we are writing mu1. In place of mu1, mu2. Here also mu2, mu1, mu1, mu2. Now let us substitute the values from the diagram. Mu1 upon V. Where is the final image formed? So final image is formed here. From C to here, C, I. So final image is formed at I. So the distance is C, I. And it is on the right side, so we write positive. And here this is U. Equation, see the equation. Now in place of U, we will write the values. U, what is U? Where is the object kept? Now for this second surface, object is here at I dash, so we will write C I dash. C I dash is equal to V1 minus V2 divided by R2. Equation number 2. Now let us add these two equations, and now adding equations 1 and 2. Let us add. Observe this mu2 upon Ci dash, and this, when you add these two equations, so this mu2 upon Ci dash positive, this mu2 upon Ci dash negative, this positive and negative, so this term will be cancelled out. So what is left? Mu1 upon Ci and this is minus, and minus will become plus. Mu1 upon C is equal to, this side you observe, this is written mu2 upon mu1 upon R, and here also if you take minus common, so we can write mu2 minus mu1 outside, and we are left with 1 upon R1 minus 1 upon R. Try to understand how it is written. I hope this you have understood. Positive and negative cancel out, and this is positive written as it is, minus and minus written as it is. This mu2 minus mu1 upon R1, here see mu2, it is written mu1 minus mu2. So I will take minus common. So minus will be written outside, it will become mu2 minus mu1. So that mu2 minus mu1, mu2 minus will be taken outside. So here 1 upon R1 here, and at this side minus 1 upon R2. So minus 1 upon R2. Now this mu1 and mu1 will be taken outside and will be divided. So we are left with 1 upon Ci, 1 upon Co is equal to mu2 upon mu1 divided by mu1 is equal to is multiplied by 1 upon R1 minus 1 upon R2. Observe this. So what is Ci? See the diagram. What is Ci? What is Ci? That is V, and it is positive. So write 1 upon Ci. So Ci, that is V. So write V plus Co. What is Co? Co, that is image, and it is kept on the left side. So write minus U is equal to. So here you write mu2 by mu1, mu1 by mu1. So we have divided. Divide by this and by this. So this mu1 and mu1 will be cancelled out. So let us rewrite 1 upon V plus minus minus 1 upon U is equal to, this will be divided and will be written as mu2 upon mu1 minus 1. 1 upon R1 minus 1 upon R2. So from the length formula, already you know 1 upon V minus 1 upon U is equal to 1 upon F. So here we can write 1 upon F is equal to mu2 upon mu1 can be written as mu minus 1 upon R1, 1 upon R2. So this we have written, from here 1 upon V minus 1 upon U is equal to 1 upon F. So 1 upon this value will be equal to 1 upon F. That is 1 upon F. So this is lens maker formula. Lens maker formula, and is very, very important. One step ahead, it can be written 1 upon F, that is equal to power. So mu minus 1 this is all about lens maker's formula. It means if in the exam it is asked derive lens maker's formula for 4 marks, so we will first derive this equation. This we will derive, that is we will start from refraction at spherical surfaces. We will derive this equation, then we will use this equation for the 2 surfaces, and we will add and we will get lens maker formula. If it is asked for 4 marks, if it is asking for 2 marks, 3 marks, we will start from here. We will directly use this equation and reach the result. So remember this, and it is very, very important. Thank you.